What's up, everyone? Vin here, and this is the June 2024 Geometry Regents live stream review. Thank you for joining and being a part of this. This is a lot of fun for me. I know it's kind of late in the game. The test is tomorrow, but just happy to be on here with people. I see we got a lot of people already here in the chat. So hello to anyone here. And for this live stream, I am going to go over the January 2017 test. This one was definitely a bit tricky. I forgot to put the sign on my shirt that says this is not the actual test, because that's one of the most popular questions I get. But I see the chat is going pretty strong here. So for the first part here, I'll just say hello to everybody. Just a few things right off the bat is just be respectful to each other in the chat, and me. That's really it. I think you all know what that means. So yeah, just be nice. But hello, and I'm happy to see you all. Another thing, I saw people talking about the curve. So for the most recent regions, the January 2024, you needed 30 raw score points to get a 65. The one I'm doing, they were less generous. And this one, the cutoff was a 34, which is 17 multiple choice. Remember, try not to put all of your faith in the multiple choice questions. You want to try to get as many points as you can from the free response. That's one of probably the biggest mistakes people make is they just think, oh, there's no way I'm getting any points from the free response. So if you want to pass, you definitely have to be able to do something in the free response part of the test. So just floating that out there. Let me just see. Let's see, inappropriate, blah, blah, blah. Yeah, I mean, you just writing down some work and showing any signs of life, like knowing a formula. The people grading your regions, I know when I'm grading regions, like I want to see you all do well. So, please put some work down so we could help you. All right. Oh yeah, and what I'm gonna do is I am gonna put the chat in slow mode. So if people spam, please don't spam. No one likes that. So slow mode, no more spamming. Okay. So now you could only send a message every 20 seconds. Cool. Oh, if you weren't invited to the regions by your teacher, that's more like assistant principal, guidance counselor territory. Teachers have really no power to sign anybody up for regions. Okay. So you have to ask like an assistant principal or something. So yeah, that's your best bet. Blah, blah, blah. How many multiple choice do you need to pass? These days, around 15. Okay, so yeah, that seems to be, at least on the most recent regions, that was the cutoff. So if I pull up the January 2024, so I'll just take a screenshot of this. This was the most recent one, and I'll put this right on the main page here. So let's just see. Actually, let me try this again. But I don't know, maybe you're able to see this. Let me just expand this a bit. Right, here we go. Okay, yeah, it's not the best quality, but you could see 30 points. That's 15 multiple choice questions. They're worth 2 each. Would have gotten you a 65. Okay, and that was January 2024. So in prior, like older exams, it was less, but then they kind of lightened up a bit. All right. Let me just see in the chat any other questions here. All right. Cool. So moving on here, we will, I guess, wait, I'll just keep taking some questions. Proofs are, okay, yeah, I do have a proof at the end. Now look, the proof, unless you're going for 100, right? Like it's okay if you lose out on, let's say it's a proof for 6 points, triangle proof. My best advice, if you're just like, hey, I want to get some points here, I don't think I'm going to get 6 out of 6, then just try saying as many smart things as you could say. Like they're probably going to make you make use of like alternate interior angles. Maybe vertical angles are congruent. So if you could identify a pair of alternate interior angles that are congruent and just make that statement, they could be like, oh, cool, +1, +2 if you say 2 smart things. So you say the givens and then you have to say 2 smart things and you might be starting at a 2 out of 6. And then those 2 points might be the tipping point. The problem is most people leave the proof blank, and then it's like, no, why'd you leave it blank? Can't help you at all. Okay, so we'll talk about that though. But it's almost always like alternate interior angles are congruent or vertical angles are congruent. But with alternate interior, you have to say the whole long-winded phrase. When parallel lines are cut by transversals, the alternate interior angles formed are congruent. All right? Cool. So that is... All right. Let me just see. Blah, blah, blah. Oh, how many kids do you have? I have 2 kids. Yeah, 2 boys. So let's see. So when am I going to go through the test? Right around nowish. I'm just saying hello to people before I just get rolling here because I said 8 o'clock start, but yeah, here we go. Cool. Alrighty, so moving on. Oh, hello to Muhammad. So one of my own students. Alrighty, so let's get rolling here. And wow, we already have 284 people hanging out with us. So thank you for stopping by. Alrighty, now multiple choice. We have which equation represents the line that passes through this point and is parallel to this line. So just know parallel lines have the same slope. Okay, this is a big idea. Same slope. So then from here, what you could do, and just visualize this. You have 2 lines that are parallel. Same slope means they're going in the same direction. Okay, slope tells you direction. All right. So, so calculator trick. You ready? So let's say, oh no, I don't like writing the equation of a line. Well, I mean, for this one, they would have to give you 2 points for you to use the calculator for this. But there's 2 formulas you could use. You could use y equals mx plus b. So you could use this, or you could use this one. I personally like this one that I just wrote. This one is like, I would say, more common in calculus. So I'm always thinking forward. The main class I teach is, this year I taught 4 periods of calculus BC. I taught 1 geometry. So in calculus, you use this one more than this one. All right, but they're both good. So whatever makes you happy. So let's say you call this x1, y1. Well, you want to write the equation of a line that's parallel, and it has to have the same slope. So when you're in the form y equals mx plus b, the slope is the number in front of x, the coefficient, and b is the y-intercept. So here, if we need to have a line parallel to this one, then it has to have the same slope as this line, and the slope of that line is 1/2. So then here, what you could do is you just plug x1, y1, and the slope into this formula. You could say y minus y1 is equal to 2, equals m is 1/2, times x minus x1 is -2. Now, when you're doing x minus a negative, just go ahead and switch it to plus. You can write x minus -2, but then minus -2 just changes to +2. Okay, so this is going to change to +2. But now you look and you're like, oh no, my answer's not there. You have to write this in mx plus b form. So then you distribute the 1/2, and this is 1/2 x plus 1/2 times 2 is 1. And you have y minus 2 equals. So then from here, we're going to go +2 on both sides. And we've got y equals 1/2 x plus 3. Okay, so that's this formula. What I like about that formula is it's kind of just a direct shot right to the answer. I just have the key with me here just to make sure I don't say anything crazy, but this one is good. Now, if you like mx plus b, the advantage to mx plus b, well, you could say, oh, the slope has to be 1/2. So you could just process of elimination and say not this, because if the slope has to be 1/2, see how choices 1 and 3 are the only ones that have a slope of 1/2. So that's to start this. But if you plug in, so the second way, option 2, is you would say, all right, what I'm thinking about is x equals -2, y equals +2, and the slope that we're going to use is 1/2. And watch what happens. If you plug into the formula, you get 2 equals 1/2 of -2 plus b. But if you take half of -2, that's -1. So now I have 2 equals -1 plus b. And when we solve for b, we're going to get b equals 2 plus 1, which is 3. And you see how this has a y-intercept of 3. So maybe you think that formula is easier. That's up to you. All right, but either way, 1 is going to be choice 3. All right. You can put these in the calculator. So option 3. So use the calculator. So let's say you're like, you know what? I don't want to write the equation of a line. I want to just use the calculator. You could say 1/2, and I'll show you another cool trick. Press alpha y equals enter. And you could write 1/2 x and then plus 8. So if we just start writing all the lines from the answer choices, let's say I write one of the wrong ones, like -2x minus 3 is wrong. Okay. 1/2 x is parallel to the line that we're starting with. And so is 1/2 x plus 3. They're both parallel. However, what we're looking for, see how like the red one is definitely not parallel? We want the one that passes through -2, 2. Okay, and -2, 2 is here. That's the line in pink, 1/2 x plus 3. So type everything in. Just use the calculator. All right. All right, let's just see. Let me just, yeah, remember if you say not nice things in the chat, I mute you. Okay. So let me just see. All right. Cool. All right, moving on. So question 2, now we've got, let's just see here. So we have triangle ADE is the image of triangle ABC after a reflection over the line AC followed by a dilation by a scale factor of AE over AC. So this one's definitely like a little bit tricky. What that's going to do though, think about it. If we reflect over this line, so we reflect over this, see how it's going to flip the triangle this way? And then when we dilate it by this scale factor, this is going to shrink the triangle. Okay, it's going to shrink because if you look, AE is less than AC. So if the term in the numerator is less than the term in the denominator, then this is going to be a fraction that's between 0 and 1. So it's shrinking the triangle. Now, which statement is true? Well, let's just run through these. The measure of angle BAC, so that's this angle, is the same as the measure of angle AED. This one is not necessarily true because they're not corresponding. This would be correct if they had instead named, let's say, angle EAD. Like these two angles here are going to be the same. Okay, but that's not the case here. That's not what they gave us. So this one's out. Now we have the measure of angle ABC. So that's this angle over here. And without even looking at the rest of the answer, I would say, oh, it has to match this angle. So if we look, ABC is equal to the measure of angle ADE. Those two angles are equal. All right, big idea. Just know that similar triangles, that means similar, have equal angles, okay? So have equal, or I'll just say congruent angles. Okay, this is a big idea. Once you know the triangles are similar, then their angles are congruent. And we know they're similar because they were dilated. Dilation, it's the same shape, but a different size. All right. All right, let's just see. So moving on. All right. So question 3, what do we got here? Given triangle ABC congruent to triangle DEF, which statement is not always true? Okay, so what I'm looking for here, these two triangles are congruent. So first thing I like to do is just draw them out. This is not necessarily drawn to scale. We don't know really anything about these two triangles except that they're congruent. So I'm going to draw close enough. We're just saying that ABC is congruent to DEF. All right. So see how A is in this location, B is up, C is here? The letters have to correspond, meaning if I write A first, then you see how like A is first and D is first? They have to be in the same location. If B is second and E is second, notice these two are in the same location. And then C is third and F is third, and they show up in the same location. Okay, so that's just very important when you're setting this stuff up, and it makes these questions very possible. So they're saying BC is congruent to DF. This one here is not always true because they're not corresponding. You see how BC is over here, DF is at the bottom. Okay, this would always be true if it was BC congruent to EF, then yes. Okay, this would always be true. But this one, not necessarily. Maybe if it was equilateral, but that's not every case. Not every triangle is equilateral. Okay. The measure of angle A is congruent to the measure of angle D, or the measure of angle A is equal to the measure of angle D. This one is always true because they're corresponding. See how they're in the same location, lower left corner. The area of congruent triangles are equal, and so is the perimeter. Okay, perimeter of congruent triangles match. So this one here, we have this CP, CTC. Corresponding parts of congruent triangles are congruent. All right, awesome. So question 4, what do we got here? All right, a diagram of the, we have a diagram of this triangle. We have DE, DF, and EF are mid-segments. Okay, so the mid-segments connect the midpoints of a pair of sides. So that would tell us here that in this case, what we have is this line segment here is congruent to this one. This one is congruent to this one. Okay, and then this one is congruent to this one. All right, that's what we're given. Do we know anything else about the triangle? Well, let's see. We're finding the perimeter, so we're going to add everything up of ADEF. So we're finding this. All right. Well, one thing to know about a mid-segment is that it connects the two midpoints. But if I focus on, like, let's say this one here is half the length of this one. And they're parallel. Okay, so when you connect two midpoints of a triangle, it forms a mid-segment, which is parallel to the third side and half as long. So that means that this one here, if I put the notches, is going to get a double notch like this. All right, and now if we look, you see how EF is parallel to this one over here. And the mid-segment, like we said before, is half as long. So if this one gets a single notch, then this one is going to get a single notch as well. So then if we're looking for which one of these is equivalent, well, then all we have to think about in this case here is, I mean, let's say I put some letters here. Let's say I use X's and Y's. Maybe that'll be easier. If I put an X here and an X here, the whole thing is 2X. Okay, but this piece here is just X. All right, you see that? Like this would be X, this would be X. If this is Y, the whole thing is 2Y. And then this piece is just Y. So the perimeter of this highlighted quadrilateral would be X plus Y plus Y. And that would be 2X plus 2Y. But if we look, see how 2X is equal to AB. Okay, AB is the, like 2X represents the length of AB. And then 2Y, whoops, I should have wrote the Y's here. So 2Y is going to equal the measure of AC. Okay, so this one here should just work out to choice 4. Okay, so this one was a pretty annoying question because it's very algebraic. Alrighty. So moving on. So what do we have here? In the diagram below, if triangle ABE, so let's see, triangle ABE is congruent to triangle CDF. So these two triangles are congruent. And AEFC is drawn, then it can be proven that this quadrilateral here is one of the four. Okay, is it a square, rhombus, rectangle, whatever? Well, if they tell us that ABE is congruent to CDF, we could say that these two line segments here are the same. We could also say that corresponding angles are the same. So you see like angle BAE, the vertex being at A, this would be congruent to, if I look at BAE, that would be congruent to DCF over here. So now what I'm seeing is alternate interior angles are congruent. So then I also have a pair of parallel sides here. So now, remember, in a quadrilateral, if one pair of opposite sides are both parallel and congruent, that means so far that we have a parallelogram. Okay, so we definitely have a parallelogram. Now, can we prove that we have a rectangle? Here, I would say this one's going to stop at parallelogram. All right, it's not a rhombus because we could show it's a parallelogram. So it's like a parallelogram is like a stronger case here. So rhombus we could chop out. But why can't we say that we have a rectangle? Well, we can't guarantee anything about the other diagonal over here. Okay, to show that this is a rectangle, we would have to be able to prove the diagonals are congruent. But we can't say anything about BD. And now, why can't we say it's a rhombus? Well, we don't have enough information to talk about this triangle over here. Because all we have right now is, let's say, I could say these two line segments are the same. We know that these two angles over here are the same. So that would be able to tell us that these two angles are the same. And if I'm able to show that these two angles here are the same, I still can't really get to the rest of this yet, saying like, oh, these triangles, all four are congruent. Like that's not necessarily the case. So this is going to stop at parallelogram. Okay, like that's just, once again, how this is jumping out at me. In order for this to be a rhombus, okay, so to really like maybe simplify this a little bit more, how do I know this is not a rhombus? Once again, is I would have to be able to show that all four of these triangles are congruent, because then all four of these sides would be the same. But even the way it's drawn, you could kind of see like these two triangles are not the same. All right, so that's how I'm convinced that this is not a rhombus. And if it's not a rhombus, it's not a square. So yeah. All right. So under which transformation would A prime, B prime, C prime, that triangle, the image of this, not be congruent? All right, so anytime your image is not congruent, it's shouting out dilation. A dilation will make your triangle or shape bigger or smaller. So right away, 6, I'm like, oh, dilation. Reflecting a triangle keeps it congruent. Like if I have a triangle over here and like here's the XY axis, if I flip it this way, it's going to be the same size. If I spin this, it's going to be the same size. And if I slide it 3 units to the right and 2 units down, it's the same size. Dilating it with a scale factor other than 1 will make it a different size. Alrighty, moving on to the next part. So I just gotta stay hydrated. So next up, and oh, so yeah, hello at Fortnite, Sweaty Kid. I know you've been coming to the live streams for a while. Yeah, anyone who took chem, I hope it was okay. If I had to take a chem regents, I took my chem regents like way long ago. It was so long ago. That's definitely a tricky test. All right, so let's see. The diagram below shows 2 similar triangles. And we want to know if tangent of theta is 3/7, what is the value of x to the nearest 10th? All right, let's just see. All right. So this one, the first thing I would do is just think SOHCAHTOA. So let's see, SOHCAHTOA. So we have this, and tangent theta is 3/7. Remember, tangent is the ratio of the side opposite. So if I'm looking at theta, I'm looking at the side opposite over the adjacent. And opposite means across. So I'm here, and that would be the opposite side. And then the adjacent side is the one that it's next to. Now you might say, wait a minute, is it this one or this one? But adjacent is going to go over here. The reason being the side across from the right angle is the hypotenuse. Okay, so that's just something to know here. Alrighty. So for this, like once I get to that part, that's when I start labeling stuff. Okay, like that's when I will yeah, that's when I will do that. Just want to, let me just see. All right, cool. So now what we do from here is I'm just going to label with the ratio they gave us. So here we have tangent theta is 3/7. So I'm going to put that by the opposite, and by the adjacent, I'm putting the 7. So what is the value of x? Well, if the triangles are similar, this means that the corresponding sides are in proportion. So here, what I'm looking at, see how they marked this angle the same in both triangles? And what we had is theta was the angle that was not marked. So I could put a theta over here like this. If these two triangles are similar, that means their angles are the same. They're congruent. So if this angle is 90 degrees and this one has this mark that I highlighted in yellow, then the other angle has to be theta. So then over here, tangent theta, opposite would be this, and adjacent would be next to. The hypotenuse is across from the right angle. So then what we have is 3/7 is equal to tangent theta, but so I have tangent theta is 3/7, but I could also do tangent theta in this triangle and write 2.4 over x. All right, and now we just cross multiply and do the algebra. 3x equals 2.4 times 7. So now this is where the calculator will come in. And let's see. Yeah, look, just a friendly reminder, if you write silly things in the chat, I'm just going to mute you. And if you say something like really inappropriate, then I'm going to report it. So that's your call. But please just keep it real. I mean, it happens like basically every live stream, but you know, it's, if you just came here to be, you know, like an edgelord or whatever they call it these days, please don't. Alrighty. I'm just doing the stuff ahead of time. So here we are. All right, now I just have this up here just so it's ready to go when we need it. All right, so this equals 16.8 when we multiply. And then we divide both sides by 3. Cool. So x equals, and then we have 5.6. All right, and just make sure, yep, we are good. All right, so these triangles here were similar. That was the big idea. Let me just get rid of this. Now this I'll just erase. I'm just showing you where tangent theta came from. This is really all we needed to set up. Okay, so question 8. This one I thought was like kind of unfair. It was very tedious. I mean, I was able to cheat on this one because in calculus, you learn that the biggest area for the rectangle would be basically if you make it into a square. So I just knew that, like, oh yeah, make the length and width equal for your rectangle. Otherwise, you just have to kind of do trial and error here. Like if you want to make this into a square and you have 64 feet of fence to enclose a rectangular vegetable garden, you divide this all by 4 and you're going to get 16. So if the sides here are all 16, then the area would be 16 squared, which is 256. Okay. The problem though is that when they tell you what if the length is 2 more than the width, then you have to start doing stuff like this. Like you turn it into a rectangle. If you call this x, you say this is 2 more. So then this would be x plus 2, and this would be x. And if you do the algebra, x plus x plus x plus x is 4x, plus 2 plus 2 is 4. And you set this equal to the area. I'm sorry, not the area. The perimeter is 64. So you see, I'm just like adding everything up, going all the way around. This would give me x equals 15, which would then allow me to do 15 plus 2 is 17 times 15. And let's see, 225 plus 30 is 255, I think. Let me just check that. All right, but you could basically like just start going down the line with this, which I don't like this question because it's kind of time consuming. Yeah, 255. But then you're like, oh, this is already less. So this one's the biggest area. But as you do this more and more, then it just keeps shrinking more and more. Except like choice 3. I'll leave this up to people to do. You know, I would do like x plus 4 and x. And if I call this x plus 4 and x, then the equation would just change to 4x because I'm doing x plus x plus x plus x plus 8. And I set this equal to 64. Okay, and then I get a new x. And then when I plug in and find the area, this number is just going to keep getting smaller and smaller. So 1 is it. Okay. How'd I get 17? Once you find out that x is 15, if you plug it back in, you're going to have on the bottom 15 plus 2, which is 17. Okay, so this would be 17 on bottom, 17 on top, 15, 15. So yeah. Alrighty. So moving on. Let's just see. So the diagram shows this rectangle with diagonal BD. And we want to know what is the perimeter of rectangle ABCD to the nearest tenth. Yeah, this one here was a kind of a tricky question because you had to use trig to get this. So here, I'll rewrite SOHCAHTOA. Yeah, this was like a very trig-heavy question. And if I put an x here, I could say sine of 30, because this is a rectangle. This is a right angle, which means this is a right triangle. And sine is the ratio of the opposite side over the hypotenuse. So opposite of 30 is x over the hypotenuse is 12. So then x equals, let me just see, 12 times sine 30. And from here, sine of 30 is a half. But let me just show you some calculator stuff. So your calculator, if you reset it, is going to be in radians. I would just keep the calculator in degrees for the whole Geometry Regents. In Algebra 2, you'll switch it over. But for this test, like you really just mainly want to keep it in degrees. And I press 12 sine 30, but sine 30 is a half, so this should work out to 6, and it does. Okay, so then this one is equal to 6. So if this is equal to 6, then this is equal to 6. So we're going to find eventually going to find the perimeter of the rectangle. But now what we could do is once we know that this is 6 and this is 12, let's say I call this y, I could use Pythagorean theorem. I could say 6 squared plus y squared equals, make that neater, equals 12 squared. Then I have 36 plus y squared equals 144. And then we have minus 36 on both sides. And let's see, y squared is equal to 108. So that means y is equal to the square root of 108. And to the nearest 10th, I'm just going to use the calculator. So this is square root 108. This is square root 108. We're just going to add up these four sides. 6, 6, radical 108, radical 108. Yeah, if you know it's a 30, 60, 90 like that, it makes things go way faster. So, yeah, that's definitely, and that's good for like the SAT and stuff too. So it's radical 108. Now, you could say radical 108 plus itself, or you could just multiply it by 2. Okay, so let me just clear that out. 2 square root of 108. So I just double it. And then plus, there was 6 and a 6, which makes 12. And that's 32.784. And then 32.784 to the nearest 10th would make 32.8. So choice 2. All right, moving on. And thank you everybody for stopping by. For one, I mean, I got to just 872 of you on all at once. Like that's just so awesome. No class sizes cap out at 34. So this is like really just so cool to have so many of you here. So thank you for, being a part of that. All right. So let's see here. We have we've got A, B, C, D, E, and this is the new pentagon after a sequence of transformations. So what are they asking now? Identify which sequence could map this one. So this one here is the pre-image. So pre-image, and it's going here. Now, one thing I like to do is I will think about how do I get from this point to this one. Like A and A double prime are the ones that are going to match up. Well, let's think about it. If it's mapping onto, that means these two here, like this word, says that these two are congruent. So if they're congruent, then we're not going to dilate. Okay, dilating would make this bigger or smaller. So yeah, that's not going to be a good one. Now let's see what else. The arrangement of the letters. The fact that it's going A, B, C, D, E like this. See how it's going clockwise A, B, C, D, E? But then if I go this way, it's not A, B, C, D, E anymore. It reverses. So the fact that there's a reversal means that there needs to be a reflection. So looking at this, I'm like, all right, a reflection has to be there. So it's a line reflection followed by a translation. That one is looking like it. The reason why 3 is jumping out at me is, let's say I reflect it this way. I go here. Okay, so I'm going to go like this. Like I'm flipping it over. Like this is our line of reflection here. And then I send it. So here's the shape. So I reflected it, and now I'm just going to slide it. See how it lands? All right, I'm not the best artist in the world, but that's why. So this one, you just use your imagination or draw. Drawing really helps in geometry. Like, it's a visual subject. So yeah, just make sure that you are able to see it. All right, what is the approximate volume? So volume time. So here we have a solid metal prism, has a rectangular base with sides that are 4 inches by 6 inches and a height of 4 inches. All right, so 4 by 4 by 6. And a hole in the shape of a cylinder with a radius of 1 inch is drilled through the entire length of the rectangular prism. So what you have to be able to imagine here is like this is going all the way to the back. Like when they drill all the way through, it's going like this, like all the way through the shape here. So what I'm imagining is the total volume of the rectangular prism here is 4 times 4 times 6. And if we do that, 16 times 6 is 96. Okay. Yeah, so that's, 96. And then from there, what we have to find is what is the area of this shape that's being cut out, okay? Because if we're drilling this through, just imagine a drill going through this, then what we're going to do is this shape that we're talking about is a cylinder on the inside. And the volume of a cylinder is pi r squared. Okay, let me just make that neater. Pi r squared times h. So here you see how the radius is 1 inch. But the height of this cylinder is the distance going from here all the way to here. Okay, I don't know what happens. Oh, I think it's because as more people join the live stream, my computer, like someday I'm going to upgrade this computer, even though it's a decent computer. But I think it's having trouble with all the people here, which is a good problem to have, right? There's so many people here. So now what we have is the volume of the cylinder is pi times 1 squared times 6. But think about this carefully. What is the approximate volume of the remaining solid? If this is being drilled through the entire length, think of that as the cylinder is being subtracted. Because it's drilling through means it's going to like remove that volume. It's going to be removed, so it's going to be subtracted. So then what we're going to do is 96 minus pi times 1 squared times 6. 77.15. Okay? So that's the, little bit of math that we need from the calculator. Okay, so 77.15, because once again, we're subtracting those two. All right, so 96 minus this gives us 77.15, which to the nearest cubic inch is going to be 77. All right. So let's see, moving on. Oh, let me just see. Yeah, in the chat, any questions? Oh, yeah, remember, be nice to each other. I got to get moderators that could also silence people. All right. Alrighty. Oh, yeah, Fortnite, right? You have, if you want, I don't want to give you like too much of a job, but like if you want to mute people, you can. Anyone who's not being nice. It's hard to keep track and like do the math too. I have 2 monitors, but like doing math in your head and. Alrighty. So let's see. We have a right triangle here. What is the value of x to the nearest foot? So for this one, Katoa, once again. All right, a lot of trig on this one. And let's see. So we know the side adjacent. And we're looking for the hypotenuse. Yeah, this is kind of strange. Like they kind of asked a lot of trig questions already, and now here's trig yet again. So 14 over x. A little trick, you could just swap those with these kind of questions. Just say x is 14 over cosine 40. That's allowed. Okay, if you really want to do the algebra, then just say x cosine 40 equals 14. All right, and then divide by cosine 40, and there it is. You get this, type it in. So we'll type in, and let's see, 14 over cosine 40 is 18.275. Okay, so this is 18.275, whatever was after. And to the nearest foot, 12 is going to be 3. Yeah, so I guess that my this question's mad easy if we're talking about the one I'm doing right now. I'm pretty sure everything's synced up. So for this one, they do sprinkle in some nice questions. It's not like the questions just automatically get more and more difficult. They will be polite sometimes. So that's, yeah, just be mindful of that. All right. Oh, here's a good question. This one could be a little tricky if you don't have a nice method. So now we have A and then BC. What are the coordinates of B prime, C prime after BC undergoes a dilation? All right, so this is the center. Okay, that's our center of dilation. And we're using a scale factor of 2. Okay, so I'll just say K equals 2. Usually K is scale factor. So the technique I like to use is the rise over run. So what I think of here, to get from A to B, so from A to B, what we're doing, let me make that neater, is we're going down 1. So to get from A to B, we're going down 1, and then we're going to the right 1. See, I'm going down 1 over 1. So if my scale factor is 2, then that means to go from A to B prime, remember this is my center. A is my center for everything. Then I'm going to scale this by 2. Then instead, I'm going to go down 2 to the right 2. Like I'm just multiplying this by 2. But watch what happens. If I go down 1, 2 over 2, that's going to tell me where B prime is. Okay, so B prime is at 1, 2, 3, 4, 5, 2. Okay, so B prime is at 5, 2. So right away I could see it's going to be either 1 or 4. All right, and now I just repeat this process for point C. To get from A to point C, I'm going down 1, 2, 3. So I'm going down 3. And then I'm going to the left 1. So then to get from A to C prime, my scale factor is 2. So if I double this, I'm going to go down 6 to the left 2. Okay, I'm doubling each of these. So instead of going down 3, left 1, I'm going down 6, left 2. So I'm going 1, 2, 3, 4, 5, 6, and then I'm going left 1, 2. And that's going to put me here for C prime, which is located at 1, negative 2. See the locations here, like the coordinates are 1, negative 2. And the coordinates for B prime are 5, 2. All right. So yeah, I like the rise over run method because it doesn't matter then where your center is. That just works. Cool. Oh yeah, most schools will reset the calculator for you. But yeah, if you want to see how to reset the calculator, you just press second memory 712. Okay, and then go to mode and put it in degree mode. Unless they reset it for you. All right, you have to be in degrees though, otherwise all those trig questions are not going to happen. All right, so then for this one, what do we got? More similar triangles because we have BC is parallel to DE. So since these lines here or line segments are parallel, that means the corresponding angles are equal in measure. So this angle and this angle are both going to be right. So what I think of here is I'm looking at this triangle here. So I'll do this in 2 colors. I have this triangle in green, triangle ABC. And then I have the big triangle here, triangle ADE, like this. Okay, but these 2 triangles are similar. The reason being because they told us these 2 lines are parallel. See how they share angle A? So they're sharing the same angle. Which ratio is equivalent to sine of angle A? Well, if I draw these triangles separate, see how I have A, B, C, and then I have in red, so I'll separate these 2. It's similar, so it's the same shape, just different size. I have ADE. So what this means is that the corresponding sides are in proportion with each other. So if they say, hey, what's sine of angle A? I could use either of these triangles. I could say sine of angle A is equal to opposite of A. See how this is opposite? Is BC. over the hypotenuse is AB. And right away, I'm like, oh, BC over AB. This one has to be choice 3. Another correct answer, but it's not written here, would be if instead they were like, all right, how about I use this triangle? Opposite of A is this, and the hypotenuse is this one. So we could say, like, also sine of A equals DE over AD. All right, so let's say I made like a choice 5. I don't know what just happened. Let's try that again. So DE over AD, like choice 5, if there was like 2 right answers, could say this and still be correct. Right? All right. So let's just see. All right. So okay. So moving on. 15. Circle O, we have 2 secants drawn to an external point A. So for something like this, if they don't give you a picture, I would make one. So here, let me draw this neat. I mean, I could cheat and use my program, will make straight lines. I would say use like a student ID unless you bring a ruler with you or they give you a ruler. Most schools I feel like are not going to give you a ruler. All right, so it's A, let's say this is D and this is B, and then AEC. One thing to point out, they told us A is the external point. That's outside the circle. So if it's A, then D, then B, then D is the first point that's going to happen after A, and then B would be after. I can't switch these 2 points. Like, that would be bad. All right, now, for this one, AD is equal to 8, and then AE is equal to 6. And then they told us EC is 12 more than BD. So if BD is X and EC is 12 more, this would be X plus 12. Now, the way I like to remember this, I mean, shout out to one of my old coworkers who has since retired, but she called it the wee rule. Right? The wee rule says the whole times the exterior is equal to the whole segment times the exterior. So here, the whole segment, in this case, would be X plus 8. Okay, so X plus 8 is the whole segment. That's the whole secant. Times the exterior is the piece on the outside, is 8. And we could set this equal to the whole segment here. If I did X plus 12 plus 6, that would make X plus 18. Okay, see, I'm doing X plus 12 plus 6. Okay, that's the whole thing. That's X plus 18. Okay, that would be like, yeah, saying the length of AC if we show that step. So that's the whole segment times the piece on the exterior is 6. All right, and then from here, it's just a matter of doing the algebra. So 8 times X, so I'll write that over here. Sorry, this is all over the place. 8 times X is 8X plus 8 times 8 is 64 equals 6 times X plus 6 times 18. And let's see, that would give us 60 plus 48 is 108. All right, but I would just calculator that, to be honest. Like, there's no point in doing mental math on like the big day when you have a calculator. All right, so this is 2X plus 64 and then equals 108. All right, so now minus 64. And you've got 2X equals 44. So then X is equal to 22, but please be careful. Make sure you're actually answering the question. What is the length of BD? So BD is this piece here in blue, and that's just X. So 22 is our answer. Sometimes to be funny, they'll say like, oh, like what's the length of CE? And you have to add 12. But yeah. All right. So moving on. Now, all right, a parallelogram. All right, this one, if you just know your properties, it's fast. So a parallelogram is always a rectangle if the diagonals are congruent. If you just know that, then great. Now, what I would do is, if you didn't know that, draw it out. Just draw a rectangle. Okay, and you could use your student ID to make sure it's like somewhat neat. And just, draw this in and see like which one makes the most sense. So the ones that make the most sense are probably, well, a parallelogram is a rectangle. Like if you just draw a regular parallelogram next to it, that's like not special. Like it's not a rhombus or anything. It's just like a plain parallelogram. Like let's say something like this. You'll see that in a parallelogram, the diagonals bisect each other. Okay, so that's for any parallelogram. That's why this is not special for rectangles. The diagonals intersect at right angles. It would be if you have a rhombus. Like see here for the rectangle, this angle over here is acute. It's less than 90. So that's why that's not the case. Opposite angles are congruent is true for any parallelogram. The angles opposite are the same. So one is it. Ooh, all right. These kind of questions. Which rotation about its center will carry a regular decagon onto itself? So the key is what you do is you take 360 and divide by n, where this is the number of sides. And this will equal the minimum rotation. I'll say like the minimum rotation greater than 0, because 0 is boring. Like if you don't rotate it, obviously it's the same thing. So a decagon has 10 sides. And yeah, I don't know what's going on with this. So this would be n equals 10. Okay. So then all we got to do is do 360 divided by 10 is 36. And then you're like, oh no, my answer's not there. So then what you do is you just keep counting by 36s. Like you could say 36 plus 36 and just do this repeatedly. A fast way would just be to do 36x. And then this would give you counting by 36. Okay, this is just going to, once again, count by 36 very, very quickly. So we look, and we got 36. 54 can't be it because see how 54 is between 36 and 72. All right, so that's out. Then 108 goes to 144 to 180. That skips this. 180 to 216 skips this. And you're like, oh no, I really hope it's choice 4. And there it is. It would take 7 turns. Okay, if we turn a decagon 36 degrees 7 times, then that would be it. All right, cool. So moving on, completing the square. All right, completing the square I know gets a lot of complaints. People don't like the algebra. Look, one thing I just want to point out from like a calculus teacher's standpoint, I've been teaching AP calculus for a very long time. Out of all your Regents math, I would say that algebra is probably the most important. Okay, like if you want to be ready for calculus, then yeah, do that. Oh, at Speech Guy, how am I? I'm doing all right. Yeah, I'm honestly just happy to be here, and I appreciate you all coming on here to learn some math. And I'm really wishing you all good luck tomorrow. I hope the test goes well for you. I appreciate people in the chat, the people being nice, and yeah, thank you. Yeah, thank you for being on here to study. But let's see. So question 18. We have what I like to do for these questions is I make space. So I think of, let's see, we have x squared plus y squared minus 6y, and then plus 1 equals 0. The first move I do is I just move the constants to the other side. So now I've got x squared plus I have y squared minus 6y. I'm going to leave a space here equals -1. Now, the reason why I'm leaving a space is because this is where we're going to actually complete the square. So then what I'm thinking of is the b term. Okay, that's the number in front of the x or the y. So what we mean by that is when we have something in the form of like x squared plus bx plus blah, 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 the b term is the number in front of x, and it could be the number in front of y. You need it to say 1x squared, 1y squared, which they basically always make that happen in these questions. They don't want to make the algebra, too crazy. So now we take the b term, we divide it by 2, and then we square it. So that gives you -3 squared, which is 9. That's the mystery number you're going to add to both sides. You're going to go plus 9 on the left and plus 9 on the right. Okay, so this is, how we are going to start this. And now, here is actually going to be the technique of completing the square. So what we have from this step is this is x squared plus, and now this piece, maybe I'll do this one in a different color. I'll do this in blue. We're looking for two numbers that have a sum of -6 and a product of +9. Okay? So here, the mystery numbers would be -3 and -3. If I do y minus 3 times y minus 3, that's going to give me y minus 3 squared, but I could just check -3 plus -3 is -6, and -3 times -3 is +9. And this is equal to 8. But what you really need to know for this question, like once I simplify this, I have x squared plus y minus 3 squared equals 8 is the formula. Okay, this is the formula that you need. Is x minus h squared plus y minus k squared is equal to r squared. This is the formula for the equation of a circle, center hk, radius r. Okay, so the center hk and radius r. So for this, when I'm looking at this, you might say, wait a minute, where's the h? Well, if there's nothing there, it's 0. So the center starts off with 0, as all the answers do. And then be careful. You're not going to say -3. You're going to say +3. Because notice, if the center is hk, it's x minus h squared, y minus k squared. So it's opposite. So here, -3, the opposite would be +3. So that's our center, 0, 3, which basically eliminates everything and gives us choice 1. Now you might be thinking, wait, how is it 2 radical 2? Well, it's r squared. So then r would be the square root of 8. And if I break this down, that's square root of 4 times the square root of 2, which is 2 radical 2. Okay? All right. All right. Oh, wait. Hang on. Spamming. Cool. Yeah, the center, unless it repeats, then yeah, that'll be fine. All right, let's see. All right. Okay. Yeah, I'm reading the chat to like silence some people. Yeah. Yeah, just a reminder. I mean, it's fine. It happens, like I said, every year. I think it's a sign that maybe the channel is just growing. So I'll take the trolling as a compliment. But if I see people trolling, I'm just gonna silently, mute you. So all right. Let's see. So parallelogram ABCD. We have A is at 0, 7, C is here. Which statement would prove that we have a rhombus? I mean, something like this, if you want, you could just go ahead and plot it on the scrap graph paper they give you. But let me actually draw a rhombus out. All right, let's see which direction they're going. So, I mean, I would just draw any rhombus for now. Like, let's say A, B, C, D. Not necessarily drawn to scale or like in the right position. But in a rhombus, all four sides are the same and the diagonals are perpendicular. So this is just something special about a rhombus. I didn't draw it well, but these are basically four right angles here. So what they gave us was AC. They gave us the coordinates of one diagonal. So this is the angle they want us to go with here. The slope of AC, so I'm going to write it like this. The slope of AC is equal to, and remember the formula for slope, is y2 minus y1 over x2 minus x1. And if I apply that formula, let's say I call this x1, y1, and I call this x2, y2, and I find the slope, then I'm going to have 1 minus 7 divided by 2 minus 0. And negative 6 divided by 2 is negative 3. So then what's jumping out at me right away is to prove that we have an actual rhombus, the diagonals we could show are perpendicular. And if the diagonals are perpendicular, okay, so I'll just say this, perpendicular lines, the slopes are opposite reciprocals. Opposite reciprocals. So for this, what I do with that is say, all right, then the slope of BD, the opposite of negative 3 would be positive. And then the reciprocal of 3, think of this as 3 over 1. So opposite would be positive, and then I just flip it to 1/3. All right, we don't actually write the plus, but it's there. So the slope of the other diagonal BD would be 1/3. Okay. It wouldn't be this side because if AB was perpendicular to AC, then that would make this angle obtuse, like the corner. And if it was obtuse, then I mean, no, you can have an obtuse angle, but yeah, that wouldn't be enough to prove it though. You would want to prove the diagonals are perpendicular. All right. Oh, this kind of question. Let me actually get some graph paper here. So let me find a graph. Because I'll show this two ways. You could do this the visual way. Yeah, you know what? I'll borrow this one. This is a nice graph. All right, so we have this. Now I'll go back to the question. Okay. So I'll show this two ways. If you like the formula, I'll show you how to use a formula. The only disadvantage with the formula is that the formula might not work out so nicely. Oh, no, I'm sorry. The formula will always work out nicely. The only disadvantage with the graph is if the numbers are crazy, then this is going to be trickier. Okay, so they told us M is at 3, 5. So 1, 2, 3. So that's over 3. And then up 1, 2, 3, 4, 5. So it's over here. All right, let me just see if this one is like graphable. So M is here. N is at 8, negative 5. So that's 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5. Okay, so that's N. And they told us that Q is on this line segment. So if I connect these, Q is somewhere here in such a way that it breaks the line segment into a ratio of 2 to 3. That means it's going to be 5 equal parts. Yeah, this one I think I could. Oh, actually, no, this one will work out nice. So the way to do this visually, so the concept makes sense. And I don't, yeah, hang on, let me just fix that. 5 equal parts. So this is like the concept that I'm highlighting here. is what you'll do is you'll say, all right, rise over run. So to get from m to n, we're going down 10. And to get over, we're going from 3 to 8. We're going over 5. See, I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going over 1, 2, 3, 4, 5. So if I'm doing 5 equal parts, I'm going to divide this by 5. 10 divided by 5 is 2. And 5 divided by 5 is 1. Now watch what happens. I'm going to go down 2 over 1. 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 And here is 5 equal parts. Okay. And if Q is located here, see how there's 2 equal parts at this location? This will tell us the location of point Q. Okay, see how MQ to QN is 2 to 3. And that looks like it's located at 5, 1. Okay, so 5, 1 would be it. All right, this is the conceptual way. Otherwise, this is the fast way. So the fast way is to use the formula. You say x equals x1 plus p over p plus q. This formula might be a little annoying to know. And then x2 minus x1. Just know that x1, y1 is the point on the left. Okay, this one has to be on the left, and this one has to be more to the right. Right? Otherwise, the formula is going to not work. It's going to kind of go backwards. So from this part, what you could do is you could just plug in. So we have x1, m is located here. So I'm going to call this one, let's see, this is x1, y1. This is x2, y2. We plug in, x1 is 3. The ratio here, 2 to 3, is p and q. So I have p is 2 over 2 plus 3 is 5. And then x2 minus x1, I'm doing 8 minus 3. So now I have x equals 3 plus 2/5 of 5. Now 5 over 5 cancels, and 3 plus 2 is equal to 5. All right, and then that gets me to here. But then I'm like, oh, how do I know which one's my y? The y formula is the same. Except instead of x1, I'm doing y1. And instead of x2 minus x1, I'm doing y2 minus y1. So now I've got 5 plus 2/5. And then y2 is negative 5 minus y1 is 5. And this is 5 plus 2/5 of negative 10. And then this makes 5 plus 2 times negative 2 is negative 4, which equals 1. So that's why it's 5, 1. Yeah, so this kind of question, once again, if you want the formula works, but remember, really important, they can set a trap for these. The one on the left is x1, y1. The one on the right is x2, y2. So just make sure you have that. Alrighty, so next up, and we're almost done with the multiple choice. All right, let's see. Yeah, I'm trying to read the chat too at the same time. Oh, P and Q is part of the ratio. Like P is the first term in the ratio and Q is the second term. Because if you think about the concept, like the conceptual way, 5 equal parts. If I have something that's 2 parts and then 3 parts, that's 5 parts total, and they're 5 equal parts. So when I do the rise over run method, I just divide by 5, and that tells me how to break it down into 1 part each. And notice I have 1, 2, 3, 4, 5. So Q is 2/5 of the way from M to N. That's where the 2/5 is coming from. It's because if it's a ratio of 2 to 3, then that's 2/5 of the way. All right. Let's see. Moving on, we have this circle. Angle GOJ is 60. What is the area in terms of pi of the shaded region? Well, if this is 60, the whole circle is 360. So the shaded stuff is 300 degrees. Okay, so this part here would be 300 degrees. So now the area of a circle is pi r squared. And yep, that's the formula. So here, the total area, so the total area of the circle is pi times 8 squared, which is 64 pi. But we are taking a fraction of this. Okay, how much are we taking? We're taking the shaded stuff. So we're taking 64 pi, and we just multiply that by 300 out of the total 360. They want it in terms of pi. Okay, so here, just think this is like the part we're taking out of the whole. Okay, so part is 300. The whole is 360. Depends on the school. That hopefully they give you a compass. I just saw that comment. All right, so now this, don't include the pi in terms of pi. So do 64 times 300 divided by 360. And press math, enter, enter. 160 over 3. Okay, so this is 160 over 3. And then I just write the pi. Okay, so that one's got to be choice 4. 64 is the area of the whole circle. The area of a circle, let me just fix this. The area of a circle is pi r squared. Okay, so that's like for any circle. That's the total area. But we're not taking the total area, we're taking a part of it. The part over the whole. The part we're taking is 300 degrees out of the total 360. All right. A circle whose center is in the origin passes through this point, which point also lies on the circle. So if the circle whose center is the origin is 0, 0. So I think of the formula x minus h squared. This one from before is relevant. But now if h and k are 0, this is going to start off as x squared plus y squared equals whatever r is squared. But now, I don't know, this one here, I just know r is 13 because of, this is a famous, well, maybe it's not famous if you haven't heard of it. But a 5, 12, 13 is we call that a Pythagorean triple. Okay, this is like good to know for the SAT. There's like, 3, 4, 5, 5, 12, 13. There's 8, 15, 17 is another popular one. And there's, this one's also good. 7, 24, 25. And if you know similar triangles, like I could take this one and I could double it. And I could go, oh, 6, 8, like 3 times 2, 4 times 2, 5 times 2 is 10. So these are just helpful to know. Like when I see 5 and 12, I'm like, oh yeah, 5, 12, 13. So they like using Pythagorean triples. So here, if I'm going, and it's on the unit circle. So let's just see here. Yeah, that didn't work. That was a fail. That's a little better. Something like this. Whatever, we'll say that's the unit circle. So if this is that, let's just see here. Yeah, I'll just move the point over so it's like a little more precise looking. Okay. So -5 and 12 actually is up here. So let me just put the point here. And 12. So that means I'm going to the left 5 and I'm going up 12. Okay, so if I were to plot this, you see how, let me just clean that up a little bit. Wait, no. All right, I'll get that part out of the way. So this is going up to 12. That means I go to the left 5 and I go up 12. So my triangle, if I put it over here, would be 5, 12, 13. Okay, so the radius of this circle would be 13. Because remember, the radius of a circle goes from the center, which they're saying is at 0, 0, to a point on the circle. So r would be equal to 13. We'd have 13 squared. So this would give us the formula, which I'll write over here. So let's see. X squared plus y squared equals this. Okay? All right. And now from here, let's just see which point also lies on the circle. Well, if the point is on the circle, it has to satisfy this. That means like if this is x and y, now I just check. Is x squared, is 10 squared plus 3 squared equal to that? No, this would give us 109. So it's not enough. This gives us too much. Okay, because 13 squared is already too much. And now let's see, 11 squared plus this squared. Like at this point, honestly, you just use the calculator. But that's going to give us 121 plus 2 squared is 4 times radical 12 times radical 12 is 12. And that's going to give us 40. It looks like this one. Okay, but yeah, once again, I'll show you how to type this in the calculator because you probably don't want to do that by hand. So if I did 11 squared plus 2 radical 12 squared, this is going to give us 169. Cool? Look, the theme here depends on your goal. If your goal is like, hey, I just want to get a 65, then yeah, you need like 15-ish multiple choice right. If you want to get a high grade, then like you got to know more stuff. Okay? So that's that. Honestly, like if you bring a compass to the test, you could like plot this negative 512 on the back, make a circle with your compass, and then just like get decimal values and like measure, and see like which one's most reasonable. Like that will work. Okay. Like you can use common sense, but it's good to know how to do the math too. All right. A plane intersects a hexagonal prism. The plane is perpendicular to the base. All right. So a hexagonal prism would be if you had, let me just try to draw this. So here's a hexagon. Okay. And then it's like going down this way. This. So it's like a 3D one. And there's a plane, which is like a sheet of paper. And the plane is perpendicular to the base. So perpendicular to the bottom. So if it's perpendicular, that means it's going like straight to the bottom like this. And which shape would we be looking at? We'd be looking at a rectangle. Okay, if it was parallel, so parallel, then you would be looking at a hexagon. Okay, then it would be this one here. All right, like if it was, let me see, I'll draw another one. Like this. And then it was, like a 3D one with height. Do it like this and it like goes to the bottom. Like that. And then a plane were to go through this way. You could see like if it's going this way, like when it hits, the part that it's making on the inside is like also a hexagon. Yeah, not my best artwork. 1, 2, 3, 4. Yeah, 5. Wait, 1, 2, 3, 4, 5, 6. Yeah, I drew that a little sloppy. Let me try that again. So 1, 2, 3, and then 4, 5, 6. Okay, like that would be the shape we'd be looking at. All right. Oh wow, we have serious trolling going on. All right, let me just see. I'm trying. All right, hang on. Cool. All right. All right, cool. All right, this is like a little clicking exercise, that's all. All right, last question of the multiple choice. So, a water cup in the shape of a cone. Oh, this is a tricky question. I like this question. So, in the shape of a cone, so there's the cup, has a height of 4 inches and a maximum diameter of 3 inches. What is the volume of water in the cup to the nearest tenth of a cubic inch when the cup is filled to half its height? So, for one, you got to know this. The volume is 1/3 pi r squared h. So pi r squared h. And for this, the trap here is people might just go, oh, let me do 1/3 pi and then say the radius, if the diameter is 3, they might go like this. And the height is 4. And they go, all right, that number, and then divide by 2. But be careful. All right, this one here is not so straightforward. The maximum radius at the top is going to be 1.5. Right, that is half of, like if I do 3 divided by 2, half of the diameter is the radius. And the maximum height right now is 4 inches. However, if it's filled halfway, we got to think about the concept of a cone is that the two triangles involved. See this one in black and blue? The black and blue triangles here are similar. Okay, so if this is 1.5 and this is 4, and we're going to half of the height. So that means this height is going to be 2. If we're going to the halfway point. What is this radius going to be? Well, just think about it. If I do 4 divided by 2 is 2, 1.5 divided by 2 is 0.75. Okay, so I'm not going to do this. Instead, I'm going to find the volume here. Okay, like if this is a water cup, I'm finding the volume of this cone. And the dimensions are the radius is this and the height is this. So that's what's going to be plugged in. I'm going to have 1/3 pi times the radius is 1.5. Okay, I'm sorry, the radius was 1.5. The new radius that we're going to use is 0.75. We're squaring it, and then we multiply by the height, which is 2. And if you work this out, you're going to get 1.178, and to the nearest tenth, that rounds to 1.2. Okay? All right. Oh, speed up. Yeah, I could. If you want me to speed up, I could speed up. All right. So now, moving on to the part 2s. So for this one, I need a compass. So let me just see. I believe, yep, there it is. I have this ready to go. So they said using a compass and straight edge, construct this is the phrase here, a line of reflection over which triangle RST, that's this one, reflects onto this. So the concept that you need is that when you have a line of reflection, any point from the pre-image and image, the line of reflection is the perpendicular bisector. So I could construct the perpendicular bisector between these two. I could construct it between, let's just see, I'll get a different color, between these two. Or I could construct the perpendicular bisector between these two. I'm going to do it from R to R prime because that's the easiest, the way I have it copy and pasted. Okay, but any of those would get you full credit. So I just open the compass to more than halfway, and I want to do a perpendicular bisector. So I swing the arc above, and I go below. Okay, then I move it. I don't change the length of the compass at all. I swing it above, and I swing it below. Now I have 2 points of intersection, and all I have to do is just connect them. Okay, and that is our line of reflection. Okay. Oh, at Ultra, thank you so much for the tip. I appreciate, the kindness here. That's really cool of you. Yeah, look, I will pause for a second just to say to the chat. I did send a lot of trolls out of here, but to the like 5,500 people that stopped by, and like basically like the majority, like 90% of people are like really just bringing it. Like, thank you so much for being here. This is like just a really great way for me to end my school year. I really get a lot out of doing these live streams and having this many students stop by. Like, this is like pretty awesome. I work in a school with 3,000 kids, and knowing there's like 900 of you here right now, that's like 1/3 the size of my school, is like pretty awesome. So thank you for being a part of this. The other constructions that are common, I would say, would be like equilateral triangle is big. Copying an angle would be something like you would want to know how to do. Yeah, so those, I would say, like check those out. I have videos on like all the constructions. So like if you want to like watch any of them, I have like 10 to 15 construction videos. Now let me see. Tips for taking the test. Look, I know we're anxious, and it's a lot to sit down and take a test like this. It definitely takes a lot out of you. But what I used to tell myself is like, all I had control over back then was how much I studied. And then when I'd show up on test day, I would tell myself like, all right, I studied, I prepared as best as I could. Now let me just relax as best as I can and just show up and try to do the best I can on this test. Like, just once the test gets in front of me, I'm like, all right, here we go. And I'm just focusing on the test. I'm not focusing on how well I'm doing. I really try to keep that part of my head quiet. Like, oh, you're not doing well. How many points have you lost so far? I just try to keep it rolling. So it's tough. The more you get out there and compete, though, like the better you get with the nerves. The nerves are always going to be there. They never like truly go away. But like, you're just like, all right, let's just do this. Let's sit down and take this test. So it's pretty nice. Oh, at Jefferson, thank you so much for the tip. But good luck to people. I know if you're nervous, like it's a lot, but just do your best. Okay, question 26. They love these kind of questions. Yeah, process of elimination is like definitely a great strategy. Like, common sense will really save you. Alrighty. So we're ABC, and the image is A double prime, B double prime, C double prime. We have to describe a sequence of rigid motions that would map this one onto this one. My advice is pick one point. Okay, so I'm going to take A and map it here. And I think about, well, how do I get there? Well, for this one thing you'll notice is that things are flipped. See how here it's like A, B, C going this way in a counterclockwise direction, but here it's not A, B, C, it's A, C, B. So we have to reflect at some point. So why not reflect over the y-axis? Go 1, 2, 3, 4, and then 1, 2, 3, 4. So I would say like A prime would land here. So I'm like, first, I'm like, oh, so describe a sequence of rigid motions. I would say reflect triangle ABC over the y-axis. But now think about, like, we're here. This is like our pit stop. We're here. Now, how do I get from A prime down to A double prime? I have to go down 2. Okay, so reflect over the y-axis. And sorry, that got chopped. Let me just fix that. So reflect over the y-axis. And then I would say then translate down 2 units. Okay, so then translate down 2 units. Okay, that would get you full credit. That's fine. Right? That's, yeah, more than enough. You don't have to use the notation here. You could just say it in words. So that would be good. All right, question 27. So let's see. We have this right triangle, more trig. But let's see. When instructed to find the length of HJ in right triangle, blah, 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 Alex wrote, all right, let's see. Sine 28 is HJ. So 28 is here. this side is opposite. And remember, sine of any angle is the ratio of the opposite over the hypotenuse. So just looking at this, opposite of 28 is hj, so good. So this is correct. Marlene wrote cosine of 62. So where my head goes is like, this is 90, this is 28. If we do 90 minus 28, that gives us 62. So this angle over here is 62 degrees. So that's what Marlene is doing. Marlene is using the other angle. But one thing to note here is that hj, if I'm using this angle here, that this hj is adjacent to angle h. Okay, so since it's adjacent to angle h and cosine of an angle, so cosine of some angle theta is adjacent over hypotenuse, then Marlene's equation is also good. The fanciest way to explain this would be using cofunctions. Sine and cosine are cofunctions. So that means when you do something like, let's say, sine of 30, what was it? Sine of 28. So sine of 28. And then you do cosine of 62. Like those are equal ratios because 28 and 62 are complementary. If I did sine of 40 and then I did cosine of 50, see how 40 plus 50 is 90? I get the same value. Okay, so that's what we mean by cofunctions. If you want to explain it that way, you can. But another way, I would just say, are both students' equations correct? I would answer it. I would say yes, they are both correct. Explain why. Well, why I could say that hj, so this one, is opposite of the 28-degree angle. And I'll just say here, at angle G. And then next we could say, well, I'll just say end. So I'll say end adjacent. So this is if you want to explain it without cofunctions. And it's adjacent to the 62-degree angle. Okay, so it's adjacent to the 62-degree angle. And that is angle H. Okay, and we could say the hypotenuse is 20. And now here's a cool abbreviation. This, I promise you, that means therefore. Okay, so I'm saying therefore, sine of 28 degrees is equal to cosine of 62 degrees. They are both equal to hj over 20. Okay, and that'd be fine. You just say it like that. All right, so this one we have to determine and state the measure of angle D. The exterior angle from we have a tangent and a secant. They told us here that AC, so AC is this piece, is congruent to BC. So these two are the same. Let's see how that comes into play. And, BC is 152. So if BC is 152, then this is 152. And in a circle, there's 360 total. So far, we have 304. Okay, I'm just doing 152 plus 152. Oh, at Ultra, thank you so much. Pray for you. Yeah, I'm rooting for you. I really hope you do well tomorrow. Thank you. I really do appreciate the support. But I'm rooting for you. I'm rooting for everybody in this chat that's being nice. All right, so let's see, moving on. So what we have is that there's 56 degrees left. So 56 degrees are left. So then the formula that we need, so I know I'm really color coding this. The angle over here at D, you see how angle D intercepts AC and AB. Okay, so that's just like what I'm thinking is the concept. I'm saying, oh, angle D, this angle intercepts. Let's fix that. Intercepts arc AC and arc AB. So then I'm using the formula. In this case here, I would do the difference of the arcs divided by 2. So I'm going to do 152 minus 56 divided by 2. Okay, so I subtract those, divide by 2, I'm going to get 48. So then I'll just say the measure of angle D is 48 degrees. Okay, so this one is just a formula. Difference of the arcs divided by 2, but it's the difference of the intercepted arcs. That's why I'm doing 152 minus 56. So it intercepts this one and this one. So it's like the bigger arc minus the smaller arc divided by 2. All right, prove that these two triangles are similar. So right away, I'm thinking angle, angle. That's how you prove two triangles are similar. Oh, let's see. Is someone saying not nice things? Oh, no. All right, I will. Yeah, I'll scan the chat. Remember, please be reminded. Be nice to each other in the chat. Don't say not nice things. All right. I know, like, sometimes we get a keyboard and it's exciting, but yeah. Try to be famous by saying nice things. We need more nice people in the world. Okay. So let's see. Statement. And reason. There is, in fact, a curve. You need roughly 15 multiple choice questions to pass, but this particular test, you needed 17. They've gotten a little bit more generous over the years, but yeah, that's the truth. Okay. So here, I'm just going to say the givens. So GI is parallel to NT. And what do we have? IN intersects GT at A. How do we know it's true? It's given. You have to say the givens. If you don't say the givens, you lose a point. Very sad. Now I like to mark the givens up. So they told us GI is parallel to NT. So alternate interior angles. So look for the Z shape. This one and this one are the same. And then this one and this one are the same. I could use vertical angles, but I only have to show a pair of angles are the same. So I could just say that all at once. I already said parallel. So IN intersects GT at A. So really what we could just do with this is say angle G is congruent to angle T. And I could say that angle I is congruent to angle N. How is this true? Now, this reason is very important. I would make sure to mention this. If you just say alternate interior angles are congruent, you're going to maybe lose a point. Most likely lose a point. You say when parallel lines are cut by a transversal, the alternate interior angles formed. So the alternate interior angles formed are congruent. Okay, and what I just established is two pairs of angles are the same. So see, this is like one pair of angles. So there's the angle that we need. So now I could say in the last statement here, triangle GIA is similar to triangle TNA. Reason, angle. Okay, so angle similarity. All right. So that'll do it. You can say vertical angles, like if you want to, I would just put like a 1 and a 2 here. Say angle 1 is congruent to angle 2. Vertical angles are congruent. But if I'm going to use alternate interior angles and there's 2 pairs of them, that's fine. They both use the same pair of parallel lines. All right, so next. So this kind of question, I like to think of this one as like kind of a brute force question. You just start writing in the stuff they tell you. So in the diagram below of isosceles triangle ABC, they're telling us here AB is congruent to CB. Oh, at RyanTube HD, thank you for yeah, I know I have right now 2 active mods, but thank you for helping out. Yeah, you deserve sushi. So thanks. All right. Let me just see. Okay. So next up here, what we have is we have an isosceles triangle. We have angle bisectors, which means the angles are going to be cut in half. AD, BF, and CE. Okay. So these are the 3 angle bisectors, and they're going to intersect here. Then they tell us BAC, one of these angles here, are 50 degrees. But remember, they told us this triangle was isosceles. So that means like this angle and this angle are the same. So if this one is 50, this one is 50. And if this is an angle bisector and this is an angle bisector, I'm doing 50 divided by 2. Make that, I'll write it like this. 50 over 2 is 25. Okay. So 25, 25, 25, 25. Find the measure of angle AXC. So you see how angle AXC is part of this triangle down here. AXC is here. So this triangle that I'm highlighting here in this like orange color, I just do 25 plus 25 equals 50. And then to find AXC is this one, I'm doing 180 minus 50 is 130. Okay, so the measure of angle AXC, just make this 0 nicer, is 130 degrees. And that's it. Okay, so next up, what do we have? Oh, this is a nice question. All right, this one we just have to state the coordinates of E and M. We have 2 points on a square GEOM. And we have right now G and O are the coordinates of the diagonal. So I would start by just plotting these points. So I have 2, -2. That's point G. And then I have O is at -4, 2. So that's 1, 2, 3, 4, up 2. So G and O. Now, a few things, if this is a square has a lot of properties. I'm going to say 3 things. The diagonals bisect each other. And we could say diagonals are perpendicular and congruent. Okay, that's what I'm going to use to find the other points. So here, what I could do is I could find the midpoint. Okay, the midpoint, actually they used M, that's annoying. All right, so the midpoint here, I mean, you could just eyeball it. It's like, let's see, like right around here. My eyesight is not the best. Let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So if I go down 4 over 6, I could just do half of that. I could go down 2 over 3. Go down 2 over 1, 2, 3. This is the midpoint. Okay. If I want to find the midpoint the other way, I could just take the x's. I could do 2 plus -4 divided by 2. See, like I have x1, y1, and x2, y2. I could find the midpoint by doing x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And that would give me -1, comma 0. So you see how like that's the midpoint, or I could just eyeball it or use rise over run. But the benefit of using the slope here, if the slope of OG is, I'm going down 2 over 1, 2, 3. So down 2 over 3. Then what I could do is I could find the perpendicular slope is the opposite reciprocal. It would be positive 3 over 2. So then you see how I go down 2 over 3? I could go up 1, 2, 3, and over 2. See that? I go up 1, 2, 3, over 2. And the opposite would be to go down 3 to the left 2. So I could go 1, 2, 3, and then left 2 like this. And you see there's the other points of the square. So I could call this one E, and I could call this one M. If you mix up the letters, like it's fine. They're going to give you full credit either way. That's how I like to do this. Okay, I use these 3 properties. The diagonals bisect each other, tells me to look for the midpoint. And the diagonals are perpendicular and congruent, tells me to use the opposite reciprocal to get the other points. Okay, so then these would be the 4 points of the square. But if I just draw it, then sad day at the office, I have to state the coordinates. So now I just say E is located at, let's see, if I start from the origin, 1, 2, 3, 1, 2, 3. It's at -3, -3. And M is at 1, 3. So this is at 1, 3. Cool. All right. So that's question 31. How many questions are left? Good question. Oh yeah, I'm almost 2 hours in. Oh, now we're on the part 3s. So not many. We have one more construction too. All right, so these questions now are 4 points. So on the same set of axes, graph Q prime, R prime, S prime, the image of QRS after a dilation with a scale factor of 3 over 2, centered at the origin. Okay, so the center is at the origin. So here's our center. And I would use the rise over run method again, except here it's just going 1, 2. So what I'm thinking is like, oh, the distance is like, call that like, I don't know, maybe 0.0. From O to R is just 2. So if I multiply that by 1.5, 1.5 times 2 is 3. So this would tell me to go 1, 2, 3. And there's R prime. Okay, R prime is going to be here. And now for Q, see how here for O to Q, let's make that neater. From O to Q, I'm going up 1, 2, up 2, and then to the left 2. So if I scale this by 1.5, oh yeah, 3 over 2 is the same thing as 1.5. Should have explained that, my bad. If I multiply by 1.5, I'm going up 3 to the left 3. So you see I'm going up 1, 2, 3, 1, 2, 3. That would be Q prime. Okay, and then for the last point from O to S, count the rise over run. I'm going up 1, 2, 3, 4, 5, 6. And then I'm going over 1, 2, 3, 4. It was nice they gave us even stuff, because when we multiply by 1.5, half of 6 is 3, and then 6 plus 3 is 9. So that's like going up 9, and then over 4 times 1.5, like if I do this, 4 times 1.5 would give us 6. So now from here I go up 9, and over 1, 2, 3, 4, 5, 6. So that would be S prime. Okay, and if you do this right, the triangle should be similar. Same shape, different size. Okay, so look. We have this. We have this. And we have this. All right, there it is. So there is the triangle. So we did that. That's 2 points. And use slopes to explain why QR is parallel to Q prime, R prime. Well, for this one, we could just find the slope of both. I could say the slope of QR. So this one I'll just do rise over run. From Q to R, I'm going down 1 over 2. Down 1 over 2 is negative half. So the slope of QR is negative 1/2. The slope of Q prime R prime should also be negative half. Parallel lines have the same slope. So I go down 1 over 2, down 1 over 2 is negative half. Okay. So I use the slopes here. I mean, if we want to find it manually here, that's fine. But they just said graph and label. They didn't say like write the coordinates and stuff. So I could just mention the slopes. So now, since QR and Q prime R prime so this and this have the same slope. I'll just say this like these are equal. Have actually, you know what? I'll say it over here. So these are, I'll just comment like, hey, these are equal. Have equal slopes. Then we could conclude Q prime R prime is parallel to QR. All right, so a nice little question. So that one. All right, moving on, more constructions. All right, let's see. So we have to construct a hexagon, and it's going to be inscribed in circle O. All right, that's what's happening next. So here, the trick with doing the hexagon is, I mean, I could just pick any point. Let's pick a point here. Like, let's say this one. And all I do is I construct, kind of like doing the equilateral triangle construction. Because a hexagon is an equilateral triangle just 6 times. So I get the measurement. Okay, I have this. And let me see if I can change colors. I can, cool. So I start here and I make my mark to the point. And now watch, I just place it and I just go in a circle like this. So I just go all the way around. I go 1. And now what just happened is the distance from here, here, and here is the same. So this triangle is equilateral. And then now I just move it. And I repeat the process. I go 2. And next is 3. Okay, move it closer so it looks nicer. All right, and then as long as your tick marks are there, like it doesn't have to be the most amazing like display, but let's see. Hopefully this one is like, yeah, I mean not the best artwork ever, because I probably like, yeah, I didn't get as precise as I can, but you know, I'll just say, all right, my first point was here, but you'll see when I connect these, then there's my hexagon. All right, I'll just, let me see. Oops, move that one. I mean, I'll just move this point. I'll just say like, yeah, like let's say the point was here. Like that'll be, if I had paper, it's like easier to do. Like this one's like a little annoying. But the reason why it works, so why does it work? Because you may not know it, but a hexagon is made up of 6 equilateral triangles. So I'm basically just constructing 6 equilateral triangles in a circle. Okay, and that's why it's a hexagon. Maybe that's all you need. That was the first, I haven't seen many years though where they make you do 2 constructions. Like that's pretty rare. So, all right. 34, candle. And then we have 2, oh, we only have 3 more questions, but the last ones are like really intense. So we'll just get there. All right. So what do we have here? We have a candle maker uses a mold to make candles. The height of the candle is 13 centimeters. The circumference of the candle at its widest measure is this. Blah, blah, blah. So this one here, it's a cone shape. It would be nice if they set it, because that hardly looks like a cone, but whatever. Like it's too rounded. Okay. So here, what they did to make it tricky is they told us the, oh, whoops, pi r squared h. Let me just, they told us the circumference at the base. Like the biggest circumference here, the circumference at its widest measure is this. And just know the circumference of a circle is 2 pi r. So if I want to find the volume, I have to know what the radius is. So I'm going to set 31.416 centimeters equal to, oh, and just know you don't have to write the units. So this like gets debatable, but I don't know, I like writing the units, but if you write the units wrong, you lose points. If you don't write the units, you get full credit. So it's probably not worth it for you to write the units, but you need units in physics. So I don't know. That always bothered me. So if circumference is 2 pi r and circumference is this, then set the circumference equal to 2 pi r. And then you could just divide both sides by 2 times pi. And this will tell you that the radius equals, now watch out for this. This is one of the most common mistakes kids make, like all through calculus. They go like this. They go 31.416 and they just go divided by 2 pi. And they get the question wrong. They're like, what happened? Think about it. You're dividing by 2 pi and your number got bigger. Like that shouldn't happen. Okay. So the way around it is you do alpha y equals enter 31.416 and then you put 2 pi on bottom. Okay. And you might be asking like, wait a minute. Like, why am I getting something different? Okay. Why, when I do this, is it not the same? And the reason is you need parentheses. If you're going to do it this way, you have to write parentheses 2 pi. Because the calculator is going to read this as 31.416 divided by 2, then times pi. Okay, so if you put it in parentheses, you're fine. Otherwise, just make a fraction. And this tells you r is equal to 5. Okay, don't write like 3 zeros and whatever. Just do this. So then the volume of the cone is 1/3 pi times the radius squared times the height is, they told us, 13 centimeters. Okay, and now we just plug in to the calculator. If you don't know how to find the pi button, I'll just write this one in because I wrote pi second and then this. So yeah, that'll just say type it in. But whatever, you know what? I'll type one mess in together. So for this, we could just write, let's just see. We could write 1/3, then pi, 5 squared, and then 13. You just type it just like this. Okay. And to the nearest, what are we going? To the nearest cubic centimeter is just 340. So this, I would just say 340. Okay, and then that's it. All right, you don't have to write units. All right, part 4. So the final boss is a triangle proof, 6 points. So my advice with this is to look at the model responses. What's nice about the model responses is sometimes they'll give you they'll definitely give you at least 2, but sometimes 3 responses that get 6 out of 6. And you could find your style. All right. It's a lot of different ways to get a 6 out of 6. But my advice here is if you're like, no way I'm doing the proof, say the givens and try to say 2 smart things. Like say alternate interior angles or vertical angles of some kind. Like just try to say as much as you can and just hope for the best. Okay, so this one, I want to say this one actually do in 6 statements. I feel like they made maybe not a mistake with this, but they actually left it open to be done in less. So statement and then reason. All right, so the givens is the most obvious stuff, but you have to say it. All right, I'm gonna just say here. So quadrilateral ABCD. We have AB is congruent to CD. So the givens you just have to write. It's very annoying to write this. And so then you have this. I'm just going to say like blah, 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 blah at points F and E. Okay, just for the sake of time. All right, but tomorrow I'll just write it out. When I wrote it out on my paper, I wrote it all the way. Okay, but for the sake of the stream, like blah, 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 givens. Okay. So here, if we translate the givens, they told us AB. So let me put this in red. They told us AB is congruent to CD. So that was this part. Then they told us AB was parallel to CD. We have this. So that's two things we have. And then they told us the next part that BF and DE are perpendicular to AC. So if BF is perpendicular to AC, that means we have a right angle here. I could also say this is a right angle over here, like this piece. And we have DE is perpendicular to AC. Right angle, right angle. And our goal is to prove AE is congruent to CF. So AE is congruent to CF. All right. So that is the ideas. So we have CDE congruent to ABF. Actually, this one, technically, I would need more statements and reasons than 6. But yeah, you could say this in like, yeah, actually this one, let me think. Probably 8 statements you could get away with. All right. So here there's options. How do we want to do this? Well, let's think here. What do we have so far? So this one, we could go maybe angle, side. Yeah, angle, side we could use. Just thinking out loud. So here, notice that the green stuff is part of this triangle and this triangle. So our goal, like in terms of coming up with a strategy, like you want to have a strategy for these. I would think like, ooh, let me prove that triangle ADE is congruent to triangle BCF. Yeah, I was going to say there's a way to show it by showing these two triangles are the same, but then you have to use the subtraction postulate. So that's up to you, like what you think is easier. I'll go this route because I feel like they might want you to prove you have a parallelogram. So here, what I might just get out of the way first is I'm going to say ABCD is a parallelogram. And how do we know? Because they told us one pair of opposite sides are congruent and parallel. Okay, so one pair of opposite sides are congruent and parallel. Okay, the other way of showing you have a parallelogram is if both pairs of opposite sides are parallel, or if both pairs of opposite sides are congruent. That tells you have a parallelogram. So what you could say from there is now we could say that since we have a parallelogram, I could say that these two sides are congruent and also parallel. Okay, so I'm going to say that in one statement. I'm going to say AD is parallel to BC. And I'm going to say AD here is congruent to BC. All right, and the reason in a parallelogram, it's kind of like the same idea as the statement reason 2. In a parallelogram, opposite sides are congruent. And parallel. Now, why did I say that the lines are parallel? Is I can't use alternate interior angles here. Like I want to say that this angle here, like angle 1 and angle 2 are congruent. But I can't say that unless I establish that these lines are parallel. Because a common mistake is people might say, oh, wait, alternate interior angles, like anytime I see a Z. But notice in the beginning, we already established, like we have it given that AB is parallel to CD. So I could prove like these two angles are congruent right away, but I have to say these are parallel if I want to say alternate interior angles. So don't leave that out. That's a common one that students leave out. So next, I'll just say this. I'll say that angle 1 is congruent to angle 2. And now I'll have to write that long statement out again. When parallel lines, okay, are cut by a transversal, the alternate interior angles, formed are congruent. All right, so now I have to shrink this so I could keep writing. Let's just see. A group, stay together. All right, so hopefully, yeah, everyone's got this. All right, because I have to continue the proof. So now for 5, so now I'll continue this. So think about what we have so far. I said that we have one pair of sides congruent and a pair of angles. And my goal is going to be to use angle, angle, side. Now I'm using angle, angle, side because you see these are both right triangles. They have right angles in there that are congruent. But for proving right angles are congruent, first I have to name them as right angles. So let's say here, I call this one angle 3 and this one angle 4. I could say angle 3 and angle 4 are right angles. And why is that true? So how do I know that those are right angles? Let me just clean this up. So these are right angles because perpendicular lines form right angles. I still didn't say that they're congruent yet. To use angle, angle, side, I have to say that they're congruent. Okay, so let me just clean that up. All right, so far, I have the angle on the side. I need the last pair of angles. And now I could say angle 3 is congruent to angle 4. These are congruent. And why? I could say all right angles are congruent. Now, what do we have at this stage? We established AAS. So now I have to just say it formally. I have to say that triangle ADE is congruent to triangle. Now be careful. I'm starting at A, going to D, then to E. So then over here, I'd have to go from, if I went from A to D to E, then I have to go from C to B to F. Corresponding order. AAS. So then why is AE congruent to CF? Because CP, CTC. Corresponding parts of congruent triangles are congruent. If you don't think you're going to remember those letters, just remember constipated people can't take craps. That you won't forget. Okay. Cool. We're good on 35. I think that's good. Let me just double check. So givens, parallelogram. We have parallel congruent, alternate interior congruent. 3 and 4 are right angles. They're congruent. So there's AAS, CP, CTC. Cool. Final question. Somehow we made it. All right, this question's like pretty bad. Not going to lie. This might be harder than the proof. It's debatable. All right. So we're at, oh, we're making decent time. All right. Oh, let me see. Alrighty, 36. So streetlights will be installed along a section of the highway The post for the street light will be 7.5 meters tall and made of aluminum. Cylinders or rectangular prisms. And the cylindrical posts have a hollow core. This is big. With aluminum 2.5 centimeters thick, and the outer diameter is this. Okay, so this is important. The rectangular prisms also have a hollow core. This, square base, this. All right, so for one, just visualizing this might be tough. So they're the same height, so that's cool. But they have a hollow core. So what I'm imagining here is like, try to draw this as nicely as possible. This will allow me. So there it is. And if it has a hollow core, it's going to be like this. Okay? So that's the first one. And then the second one is a rectangular prism. So there it is, like this. Okay. And there it is. All right, let me just fix that. Okay, so hollow core. All right. So hopefully we could, imagine this. So now what we want to know is the volume of this. So what's tricky about this is that this space here, once again, is hollowed out. Like this space on the inside is hollowed out, like it's missing. So here, for one, you have to know the volume of a cylinder is pi r squared h. That's on the reference sheet. And the volume of this one is length times width times height. But how do we account for the hollow core? They told us for the cylinder, the outer diameter is 53.4. So you see this entire space here is 53.4. Okay, so that's this space. However, they're telling us that this space, the thickness of the aluminum is 2.5 centimeters. But notice like this is 2.5 and this is 2.5, like here and here. So what we want to do here is the volume from here that we're finding is the volume of the whole thing is pi times. Now, one thing we could say here is maybe the radius. So the radius is 53.4 divided by 2. Okay, so the radius, I'll just do that out. That's 26.7. We start off pi times 26.7 squared times the height of this thing is, this is where we have to be really careful. The height is 7.5 meters. They really went, like, this was evil, this question. 1 meter is 100 centimeters. Okay, so if I wanted to find, 7.5 meters in centimeters, there's 100 centimeters for every meter. And like this just cancels. Oh, conveniently that canceled out. And that's going to make 750 centimeters. Okay, so to go from meters to centimeters, you just do times 100. So the height is 750 centimeters. The units have to match. That's why like they say, oh, don't write units, but if you're bad at units, then like you're not going to do well on this question. Okay, so when we plug in here, be careful. It's going to be 750 centimeters. Okay, cool. So now we have to think very, very carefully. Okay, we are subtracting out the red stuff. So I want you to imagine like we take the red stuff out. If the entire distance is 53.4 and this distance over here is 2.5 and this is 2.5, we're chopping 2.5 off of here and we're chopping 2.5 off of here. So just the red, like just this piece going across, that distance is 53.4 minus 2.5 twice is 5. Okay, and if I subtract that twice, let's just see. If I do that twice, that's 48.4. Okay, so that's 28.4. That's the diameter of the inside. Okay, that's what makes this tricky. Once again, it's 2.5 thick, so that's like going all the way around. So 2.5, 2.5. So that means we're subtracting off 5, and the inner part is 48.4. That's the inner diameter. Okay, you can even see 48.4 plus 2.5 here plus 2.5 here would give you this. But that's the inner diameter. The inner radius, I'll call it like our second radius, is 48.4 divided by 2, which is 24.2. Okay, so we're going to subtract pi times the inner radius is 24.2 squared, and the height is still 750 centimeters. Okay, so this is the, I'll just say the volume of the, the cylindrical. Did they say cylindrical or cylinder? Yeah, so I'll just say the cylinder post. Okay, so for this, now we just type that in. So you do pi times this square times this minus blah, blah, blah. And if you work that out, I'll just let you type that in because that's just typing. You get 299825.7489. Okay. I mean, you know what? I'll do it once, and then for the other one, I'll let you do the prism. So yeah, I do pi times 26.7 squared times 750. And then just go minus pi times 24.2 squared times 750. And I get this. All right, 299,825.7489. All right, that's where it was coming from. Cool. So that's this volume. And the units here, just so you know, are cubic centimeters. Okay, so the volume of the cylinder post, this is in cubic centimeters. So now we could do the same thing for the next shape. All right. But what we could also do here, they're telling us the density and how much it costs per kilogram. So what is going to be the cost? So I'll say the cost of the cylinder post. Oops. Equals, we're going to take this. That's why I like writing the units for questions like this. Times, they told us 2.7. Oh, let me write the units. 2.7 grams per cubic centimeter. And then times, it's 38 cents per kilogram. All right, the annoying thing here, though, I'm going to put one more conversion factor. 1 kilogram is 1,000 grams. And then I'll multiply by 38 cents per kilogram. Okay, because now watch, the units cancel. Cubic centimeters gone, kilograms gone, and grams are gone. And now you just work those numbers out. I promise this works out to 307.62. Okay, I'm just doing this number times 2.7 divided by 1,000 times 0.38. And you get this. All right. Cool. So now for the other one, for the second one, let's write in the dimensions. They told us that the rectangular prism has a hollow core, still 2.5, okay? And the outside is square base, so it's 40 and 40. So this part here is 40 centimeters, 40 centimeters, and 750 centimeters. So this one for the, this I'll say is for the rectangular prism. We'll just say, the volume of the total thing is 40 times 40 times 750. But then minus what is not going to change is the 750. So I'm going to say something times 750. What is going to change is that if we, if we chop off like 2.5 and 2.5, you see like this is 2.5. And this is also 2.5. Then the length and width are losing 2.5 twice, which is 5. So I'm just imagining here the inside of this thing. Like if I take just the inside out that I have color coded in red, like this, not drawn to scale, but that's 750. And if I subtract 5, I get 35 by 35. Okay, so that next piece is going to be 35 by 35. So I have 40 times 750 minus 35 times 35 times 750. Okay, and then just type that in a calculator. And the volume here is going to be 281. So 281 and then 250. All right, almost done. And now same craziness here. The cost, I'll just say cost this time. I don't feel like writing all that again. So the cost is going to be 281, 250 cubic centimeters times it's 2.7 grams per cubic centimeter times 1 kilogram per 1,000 grams times 38 cents. Like this, units cancel. See, centimeters over cubic centimeters is gone. Grams over grams, kilogram over kilogram. And if you do this times 2.7 divided by 1,000 times 0.38, the cost here would be 288.56. Okay, but now the actual question is, if all the posts must be the same shape, which post design will cost the town less and how much money will be saved? Well, the one that costs less is the rectangular prism, is 288.56. And how much less? We just subtract those two prices now. Okay, so we could just say the rectangular design costs less. Let's see how they phrased it. The rectangular prism design, I'll just say. All right. So the rectangular prism design costs less. Okay, let me just make sure. So yeah, the rectangular prism design will cost less. All right, they put a hyphen there, so whatever, I'll just put it cost less. And let's see, all right, the money saved. So I'll just say the savings equals, and I'll just say, what was it? 307.62. So 307.62 minus 288.56. And that'll equal, if you subtract those two, you will save $19.06. Cool. All right. Yeah, that is the end. Last question. Finally, we got through. Yeah, it's always a great feeling when I get to the last question. All right. Well, that is it. If you have other questions in the chat, I mean, probably just like talking questions. I feel like I just did a lot of math. But yeah, I mean, I will say once again, thank you for everyone who stopped by. We had 8,820 people stop by to this live stream. Do I think the regions will be similar? Wait, do you think this regions will be similar to this new regions? Yeah, I mean, at Fortnite, Sweaty Kid, it's hard to say like which test is going to be harder. It kind of like depends on their mood. Like some years I see it like they just kind of like overcook the test. And I was like, whoa, like they were kind of mean. This is a hard test, I thought. This was not like that easy. Like this volume question, like accounting for the thickness of the host and like subtracting it out and converting the units, there's just like way too many opportunities to mess up. Like I would be very impressed somebody getting 100 on this. So yeah, definitely yeah, something. Oh, Ed Jed, I'm happy to help. Thank you for sticking around, this late. To all my people, like hello to my, you know, my actual, yeah, my in-person geometry crew. If you're here, thanks for stopping by. I'm happy to help. But yeah, to everybody like here right now, just good luck. I know the trending word is, oh no, I'm cooked. That's probably the most popular comment I've got in the last, few months. But look, just do your best. I would say at this point, yeah, probably just go to sleep. If you want to wake up early and get some more studying in before the test, like, go ahead and do that. But then I would cut yourself off and let your brain recharge and then just put your best math down on the paper. All right. Um, yeah, I'm gonna do a live stream for Algebra 2 also, if that was some questions. But yeah, everybody, yeah, wish each other luck. Definitely. I'm happy to see people lighting up the chat. And yeah, like high 90% of the people in the chat were like saying nice things. So I appreciate you all. For a 92 plus on the test, I mean, I would say you have to look at the sample responses. Like learn what you could lose points for, what has to be in your answer. Like a common thing for like those sequence of transformation questions, a sequence of rigid motions, like if you have to rotate, you have to mention the center. Some people say, "Oh, I rotated 90 degrees clockwise," and they don't say what the center was, even if it's 0, 0. So you have to mention the center of rotation. That's like automatic one off. So if you don't know those little annoying things, like you'll lose one here, you'll lose one there, and that's when you get less than a 92. So if you're trying to get like 90 and up, you have to like basically be able to grade the test. Like you have to know exactly what has to be there for each type of question. Because like as I'm doing them, I'm like, oh yeah, it's this kind of question again. I'm like, yeah, this needs to be there. This is kind of I've seen students lose points for this, this, and this. So when I'm putting my answers together, I know what has to be in my answer so that I wouldn't lose points myself. Um, but it's just do your best at this point, this late in the game. Good luck. All right. So I'm rooting for all of you, and thank you for supporting. Um, all right. So I am gonna sign out at this point, but just yeah, deep breaths. You'll all be okay. I'm rooting for you, and good luck tomorrow. Get some sleep.